All right, we're going to get started in just a couple of minutes. If anybody is outside and those inside, please take your seats. All right, let's go ahead and kick off the afternoon plenary session, Plenary 3 on consciousness and reality. My name is Dante Loretta. I'm a Regents Professor at the University of Arizona. I'll be chairing the session this afternoon, and it's my great pleasure to introduce our first speaker, Emeritus Professor Donald Hoffman from the University of California at Irvine, known for the user interface theory, which I find quite fascinating, and I recently finished the book, The Case Against Reality, very much enjoyed it, and I'm looking forward to your presentation today. Take it away.
Thank you very much. We enjoy a wide range of conscious experiences. It's estimated that we can experience thousands of flavors at least, millions of colors, trillions of smells, actually, and untold numbers of bodily feelings and sounds. And in total, there's trillions of experiences that we enjoy, estimated. And today, we now have many physicalist theories of conscious experiences, global workspace theory, higher order theories, neuronal microtubules, illusionism. And all these theories assume that space and time are fundamental, that particles inside space-time are fundamental, that complex combinations of these particles create macroscopic objects like neurons and brains, and that neurons and brains and other physical systems with the right properties create conscious experiences or the illusion of conscious experiences. And panpsychist theories, many of them, not all, but many of them assume, again, that space-time is fundamental and that particles inside space-time are fundamental, but that those particles have another aspect to them, that's consciousness. And these theories, some of the physicalist theories, have been going through various tests of their empirical predictions recently, their adversarial collaborations. And so you might think that since there's trillions of experiences, that there's plenty for these physicalist theories to have studied. So presumably it's like shooting fish in a barrel. You have trillions of experiences. Pick any experience you want to give us your theory. What is your theory of that experience? How many experiences have they got? Well, to date, there are 0. So we've been at this for quite a few decades, and as of right now, no physicalist theory can explain even one specific conscious experience. The taste of chocolate, the smell of garlic, whatever you might wish. There are 0 successes. Now that's quite remarkable, right? I mean, so no one can give, for example, a global workspace theory state that must be the state of the taste of chocolate and couldn't be the taste of vanilla. Or, a higher order theory that must be the smell of a rose and couldn't be the smell of garlic. or a theory of space, our perception of space. So the number of conscious experiences that physicalist theories can explain is 0. Now, if I told you that I have a theory of particle interactions, you might say, oh, great, well, what particle interactions can you explain? For example, electron-photon interactions or, quark-gluon interactions. If I said to you, well, I just have a general theory of particle interactions, I can't explain any specific interaction, you might think, well, why do you call it a theory of particle interactions, right? You can't explain any particle interactions. So here we are, we have these theories of conscious experiences that can't explain any specific conscious experiences. So we're in a position where we have 0, we're batting 0 on the physicalist theories. So let's talk about what is a theory. A scientific theory makes certain assumptions, and it says if you will kindly grant me those assumptions, then I will explain this other wonderful stuff. Now, every theory, because it's making assumptions, it doesn't explain the assumptions, it assumes its assumptions, right? So you can never have a theory of everything. There's no theory of everything because at best you're a theory of everything except your assumptions. So now suppose you say, well, of course you can make a theory that explains the assumptions of a previous theory. I'll give you a deeper theory that explains the assumptions. And yes, you can. That's what science is about. But your deeper theory will have its own new assumptions. And so this goes on ad infinitum. So there's, in principle, no scientific theory of everything. This is great news. It's job security for science, infinite job security for science. But it's bad news for those who want a theory of everything. So every scientific theory has a scope. Well, bad theories even have no scope. But any good scientific theory has a scope and a limits. For example, Newton, his theory reigned for several centuries. It was fantastic. It did a lot of incredible scope, but it had a strong limit. It couldn't, with Newton's physics, you couldn't understand chemistry. You needed quantum theory. So chemistry was not just a hard problem for Newton, it was the wrong problem. Newton just can't do it. So you shouldn't call it a hard problem for Newton, because that entails that if you work hard enough, you'll be able to figure it out. It's a hard problem, but you can solve it. No, it's not solvable. Newton cannot solve it. So that's the wrong problem. So, of course, after Newton came Einstein and quantum theory, and we got what we needed to understand chemistry. But I want to suggest that for physicalist theories, consciousness is not a hard problem, which means that later on we might be able to solve it, if we work hard enough. It's the wrong problem. And I'll give you my reasons for why consciousness is the wrong problem for physicalist theories. So consciousness is the wrong problem for consciousness. So why? Because the high-energy theoretical physicists themselves tell us that space-time is not fundamental reality. So this is a special branch of physics. It's not quantum theory, it's high-energy theoretical physics. And these physicists put it this way. This is a quote from several of these physicists, that space-time is doomed. But by that they mean space-time is not fundamental reality. So Nathan Seiberg says, I'm almost certain that space and time are illusions. They're primitive notions that will be replaced by something more sophisticated. Andrew Strominger at Harvard says the notion of space-time is clearly something we're going to have to give up. David Gross, winner of the Nobel Prize, says, I believe that space for sure, and presumably time as well, will be emergent. And Nima Arkhani Hamed at the Institute for Advanced Study at Princeton says, the very notion of space-time is not a fundamental one. Space-time is doomed. There's no such thing as space-time fundamentally in the actual underlying description of the laws of physics. That's a pretty strong statement, right? And then David Gross explains why. Why they're saying this. There's no operational meaning to distances smaller than the Planck length. So what they mean is the following. Suppose you want to measure something that's really small. Well, small things, you need to have a powerful microscope, right? The smaller you want to go, the more powerful microscope you need to have. What you're really doing, if you think about it, is you're getting light with smaller and smaller wavelengths, or radiation with smaller and smaller wavelengths, so that you can resolve the details of what you're trying to look at. And that's fine. With quantum physics, that's perfectly fine. You just require higher energies. As you go to smaller wavelengths, you use higher and higher energies. Here's the problem, though. Einstein tells us that energy and mass are the same thing. And as you're concentrating more and more energy into smaller region of space with your microscope, microscopes are like Large Hadron Collider. That's what I mean by microscope. These are the colliders that are looking at the stuff. Then you're concentrating all this energy into a small amount of space. That's a lot of mass in a small amount of space, and what happens is you create a black hole. You actually destroy the very thing that you're looking at. So that what that means is if you try to measure something smaller than 10 to the minus 33 centimeters, 10 to the minus 43 seconds, then space-time just gives you a question mark. It has no notion of what you could possibly mean functionally for things smaller than 10 to the minus 33 centimeters. So in summary, space-time, Einstein's theory of space-time, falls apart at precisely 10 to the minus 33 centimeters in that neighborhood. After that, and by the way, that's, in my view, pretty shallow. It's not 10 to the minus 33 trillion centimeters. It's just 10 to the minus 33 centimeters. So that's when it falls apart. So one thing to notice here is that Einstein's theory tells us that, it starts with space-time as the fundamental concept, but his own mathematics then tells us that it can't be fundamental. It falls apart at 10 to the minus 33 centimeters. That's a great scientific theory, a theory that tells you its scope and also its limits. I'll just mention briefly that evolution by natural selection agrees with the physicists that space-time is not fundamental. You can ask a technical question in evolutionary theory. Did natural selection shape sensory systems to see truths about objective reality? What's the probability of that? And when you use evolutionary game theory and check this question out mathematically, it turns out the probability is 0 that any sensory system has ever been shaped by natural selection to see any true structures of objective reality. And what that means intuitively is that evolution didn't shape us to see the truth. Evolution shaped us to have a user interface that lets us stay alive and play the game of life. And the intuition is, for example, if you're trying to write an email, what you're doing in your computer as you write an email is you're literally, in the truth version of this, you're toggling millions of voltages in your computer in a precise order. Now, you could do that. You could go in there and toggle those voltages, but it would take you a while. Probably none of us would do it, and we would never send emails. So what do? We do toggle those voltages, but not directly. We type on our little computer, and we have this nice little user interface, and it hides the truth, all the voltages and diodes and resistors. You don't want to see the truth. You want that hidden from you. And you can still, with your user interface, even more successfully, more adaptively, control the truth. And so that's what evolution did. You don't need to see the truth, you just need to control it to play the game of life. And so it hides the truth and gives you a user interface that lets you play the game of life without knowing what it is you're really doing. Or you can think of it as a virtual reality kind of headset that evolution has given us, and you're playing the game of life with that headset. And in that case, physical objects that you see around you are like the physical objects you see in a VR game. When you look at them, you render them, and that's when they exist. When you look away, you no longer render them, and they don't exist. In physics, they call this the failure of local realism. And so local realism is false, and it falls right out of this idea that space-time is doomed, and it falls out of evolutionary theory. So the idea that physical objects exist and have physical properties with definite values when they're not observed is misaligned with our best science right now. Now, so the physicists, these high-energy theoretical physicists say space-time is doomed. Again, that means it's not fundamental. That's what they're saying. But they're also saying something else. Reductionism is doomed. So Nima Arkani Hamed, again at the Institute for Advanced Study, says, so the entire reductionist paradigm, that fundamentally physics is given by some laws at the most microscopic distance scales, and somehow we must just have to go there to see what's going on, is ultimately false because of gravity, right? Gravity is the thing that creates those black holes. So he's saying reductionism is false, and we have a long history of reductionist theories in human thought and science. We used to think earth, air, fire, and water are the fundamental ingredients of the reduction. Then the periodic table of elements, thought they were fundamental, and then we discovered early in the 20th century they're not. And now our theory is that bosons, leptons, and quarks are the most fundamental elements of reality. But what are bosons, leptons, and quarks, these fundamental particles? A physicist would tell you that they're nothing but the representations of the symmetries of space-time. What they would say are irreducible representations of the Poincare group, which is just, if you tell me what the shape of space-time is, then I will tell you what particles, elementary particles, you must have. So when space-time is doomed, so are the particles. And so therefore, all of the things that are built out of those particles, so pyramidal neurons, brains, none of these things are fundamental, part of fundamental reality. But all of the current physicalist theories are assuming that space-time is fundamental and that physical objects inside space-time are fundamental, and they're assuming a reductionist framework. They're assuming that consciousness can be reduced to the activity of the brain, which can be reduced to neural activity and so forth. So, and that's why we've had a problem in these theories, as I mentioned. No single specific conscious experience has been explained. This caused Steve Pinker in his book Enlightenment Now, and Steve likes the global workspace theory, but he pointed out that the last dollop in the global workspace theory, that it subjectively feels like something, to be such circuitry may have to be stipulated as a fact about reality where explanation stops. So in other words, what these theories are doing is they're stipulating space and time, they're stipulating the physical properties, and then they don't explain conscious experiences. In fact, they explain zero conscious experiences right now. They have to stipulate the conscious experiences. So there's only assumptions and stipulations and no specific explanations of any specific conscious experiences. And my diagnosis is that this is not the hard problem for physicalist theories, it's the wrong problem. You can't boot up consciousness from unconscious ingredients. So there's, again, I've mentioned these specific kinds of conscious experiences to be very specific. So reductionism is doomed according to, again, high energy theoretical physicists. But this might be even more surprising. They say that quantum theory is not fundamental. So space-time and quantum theory, they're saying, and this is in the last 10 years, space-time and quantum theory are going to arise together from something deeper. So as Nima puts it, so there's some other structure that we're looking for, and some way of thinking about interpreting this structure that will let us see space-time and quantum mechanics emerge simultaneously and joined at the hip. So this is the current program of many high-energy theoretical physicists. And he says we're looking for structures and ideas that don't look like anything having to do with particles propagating in space-time and wave functions evolving in Hilbert space. And the point is, when you have no Hilbert spaces, you have no quantum theory. So that's why he points out Hilbert space. So, but the physicists haven't just thrown up their hands and said, oy vey, we can't do this, space-time is doomed. And they've started looking outside of space-time. And you might go, how in the world do you look outside of, what does that even mean to look outside of space-time? Well, these are really bright people, really smart people. What they look at they're looking at data from scattering amplitudes, like the Large Hadron Collider, where you crash particles together at high velocities and see what sprays out. And you look for probabilities for various particle interactions. And you can compute these probabilities inside space-time, and you get these Feynman diagrams, and it's complicated. And a small interaction like 2 gluons in, 4 gluons out could be hundreds of pages of algebra for one interaction. It's a mess. So, you know, there are gluons interacting with each other and so forth. But what they discovered about 10 years ago was when you step outside of space-time, they found these geometric objects they call positive geometries. And here's one of the positive geometries, an amplituhedron, just about 10 years ago. And when this thing actually encodes those scattering amplitudes, hundreds of pages of algebra turns into 3 or 4 terms that you can compute by hand. All of a sudden, when you let go of space-time, the ugly math goes away, and you get something that's much more straightforward in terms of the computation. And then you see new symmetries that you couldn't see before. So they actually see new symmetries, an infinite Yangian symmetry that you can't see inside space-time, but you see when you let go of space-time. And then they found these positive geometries that code for stuff inside space-time, but these geometries are outside space-time. So they're not little things curled up inside space-time. They're utterly outside space-time. And they could have billions of dimensions. They could have a small number of dimensions or billions, depending on what you want to talk about. And then you can classify these objects. There are ways of categorizing them, classifying them with things called decorated permutations. So there's the geometries and then the classification of the geometries that all in the last 10 years. All this is, so it's brand new stuff. Many physicists don't know about this. This is only high energy theoretical physics that's really working on this. So the picture is, space-time is not fundamental. Outside of space-time, there are positive geometries, like the amplituhedron. Others are sociohedron, cosmological polytopes. There are several other kinds of positive geometries. And then classifying these objects are decorated permutations. So we're in this very interesting place. Humanity has been stuck inside the space-time headset forever. At least science has. And in the last decade, we've, for the first time, taken off the headset and started to look around to see what's out there. And we're finding positive geometries, obelisks. It's like 2001: A Space Odyssey, where the apes see this obelisk that's been plopped down there, and they're hooting and hollering and pounding on it. They know it's important, but they have no idea what it is. Well, that's where we are right now. We've got these obelisks. We've discovered them, but we have no notion of dynamics, right? These are just sitting there. I mean, who ordered that? Why are these things just sitting there? But the success of these high-energy theoretical physicists in the last 10 years has been so surprising and so large that the European Research Council decided to give a $10 million grant. So they just funded a $10 million grant, and they're bringing together an international team of mathematicians and scientists, physicists, to study these positive geometries in particle physics and cosmology. So they had their first meeting in February of this year, over 100 PhDs in mathematics and particle physics. And they're working on this, and here's what they plan to do. The Universe Plus project seeks a new foundation for fundamental physics, ranging from elementary particles to the Big Bang, revealing a hidden world of ideas beyond quantum mechanics and beyond space-time. This is not some crazy stuff. This is the European Research Council. They're looking for novel geometric objects. Well, the novel geometric objects recently discovered in theoretical physics hint at new mathematical structures. And at the very bottom it says we're looking for a new mathematical framework for describing the laws of physics. So that's what's happening now. This is quite exciting. So the physicists are jumping in, and the mathematicians are jumping in and saying, space-time is doomed, get over it. Let's let's understand these new structures beyond space-time, and let's go there. This is the new generation, that's where they're going. So they found these positive geometries, and they found these decorated permutations. So, but how about our field, study of consciousness? We're still stuck with the old model. We're still stuck in space-time. And I'm suggesting that space-time is not the right way to do it. Consciousness is not a hard problem for a space-time based model. It's the wrong problem. Just like Newton could never solve chemistry, space-time models, physical models, can never solve consciousness because it doesn't have the right framework. Space-time is not fundamental. That's the key point. It's not fundamental. Particles in space-time are not fundamental. So trying to build a theory of consciousness that assumes that particles in space-time and objects in space-time are fundamental is ignoring what high-energy theoretical physicists are telling us. So I and my collaborators are saying, let's start with a theory of consciousness that doesn't start with space-time. Let's start with consciousness itself. Let's say, okay, if space-time isn't fundamental, then let's take consciousness as fundamental, and then we have the opposite problem. Instead of trying to start with space-time and physical models in space-time and boot up consciousness, we have to start with consciousness and show precisely how space-time arises. No hand wave. We have to get precise, like what is the mass of the electron, and and the spin of a photon, and so forth. We have to get all that from this theory. So we have a theory of what we call conscious agents, and I guess I need to reboot that thing. Okay. So what should a theory of consciousness explain? Well, here's a laundry list, and I'm sure if you look at it, you can think of a lot of other things you might want to explain. Qualia, free will, action, attention, learning, memory, a whole bit. This is the laundry list. Now, William of Ockham told us that when you build up a theory, you want to use as few assumptions as possible and explain as much as possible, right? So we want to use Occam's razor. What are we going to do? Out of this laundry list, we'll pick two. We pick two. There are conscious experiences, qualia, and there are actions, which we'll model as probability relationships among experiences. If I experience red now, what's the probability that I'll experience green next? Things like that. That's it. From this whole laundry list, we're picking out those two things. We're going to try to build a whole conscious model out of all of those and try to explain all the other stuff on this list. That's the goal. Assume as little as possible, explain as much as possible. And just intuitively, without going into the math, what I'm saying now, anybody wants, I can give you some papers where we do this all mathematically. We have a probability space of experiences. So each conscious agent has a probability space which models the experiences it can have, like red, green, and blue. Then, based on those experiences, it chooses what actions it might take, and that's modeled, that arrow is modeled by Markovian kernels. So it's a Markovian kernel, a square matrix, each row sums to 1. Actions are then modeled by probability spaces. Markovian kernel, you act on a network. So think of this as a vast social network, like the Twitterverse, or X, but I'll call it the Twitterverse. So a bunch of interacting conscious agents, and they're sending experiences and receiving experiences, tweeting and following, and so forth. So that's what I'm thinking about. And we're using Markovian dynamics to model this Twitterverse of conscious agents. So there's the network, and then the network affects the experiences of this particular conscious agent that we're modeling here. So that's sort of the top level, but for those who are interested, I can give you a mathematical paper on this. It's straightforward to prove that even though we only assume two little things, qualia and actions, this model that I just gave you with Markovian kernels is computationally universal. What that means is that anything that you can compute with neural nets, like ChatGPT, whatever, you can do with networks of conscious agents. So all of these things, learning, memory, problem solving, the self, and so forth, we can build models of these using networks of conscious agents, in principle. But it's also beyond computation. It turns out that these conscious agent networks are not limited to just what's computationally feasible. And that's a technical thing we can go into if you're interested. One key thing that comes out of this is that it's a Markovian dynamics, and I want to talk about one aspect of that that's pretty interesting called trace chains. So here I've got a Markovian dynamics of a conscious agent that can experience only 9 different experiences, 9 different colors. And what you're seeing is, it first experiences green, then brown, then pink, then yellow, and orange, and so forth. I can't keep up, but anyway. So that's just the sequence of experiences it's having as it interacts with this network of other conscious agents. But now suppose, so I can write down the Markovian kernel for that, but now suppose that I only want to pay attention to the lower right two, the red, green, blue, and yellow on the lower right. Well, I can see that I can also induce a probability. If I see red, what's the probability I'll go to green? If I see green, what's the probability I'll go to red or yellow and so forth. So I can actually get a little Markovian kernel on just those four. That's called a trace chain. When you take a bigger Markovian kernel and you look at, I'm only going to pay attention to a small group of states, then you get what's called a trace chain. So that's going to be critical. There's a formula for trace chains, so you can actually compute what they are. And what we've discovered is, and we haven't published this yet, so this is, we're writing the paper right now. We discovered a new mathematical feature of Markov kernels, that the set of all Markov kernels can be ordered with this, that one kernel, so one conscious agent set of experiences in dynamics, can be less than another if it's the trace of the other. So if one conscious agent, if its kernel is the trace of another conscious agent, then we would say that it's in some sense, part of that bigger agent and observes the bigger agent. So what this gives us a logic of all possible consciousnesses, right? And it's a non-Boolean logic, so this is not a Boolean logic. There's no global top, which is really interesting. There's no top consciousness in this theory. There are a bunch of infinite ones at the limit, but there's no single infinite one that's the top consciousness. So this is really an interesting structure. We're just starting to explore it. But if m is less than n, then we can actually say m observed. So we have a theory of observation that comes out of this, which is good because quantum theory doesn't have a theory of observation. So we're going to provide one here. And it's a non-Boolean logic of observation. And there's a whole logic. So it's a non-Boolean logic. Locally, it's Boolean. If I take any particular conscious agent and look at all the agents that are less than it, they form a Boolean logic. So we have an infinity of these sub-Boolean logics, but the whole logic is not Boolean. And this, by the way, for those who are interested in consciousness being fundamental, there is the problem in idealism of giving a theory of the dissociation and also of the combination. How do you combine consciousnesses, and how do you take a bigger conscious and dissociate it into smaller consciousnesses? This mathematics just does it. It tells you that the big idea is that two consciousnesses can combine if the states that they overlap on they agree about the trace. If they have exactly the same trace on those states, then you can combine them. They're compatible. And if they don't have the same trace, then you can't combine them. So this actually gives us a theory of the dissociation process that has only one definition, that if you're a trace of one, then you're less than that one. That gives you the entire logic. So it's a theory of the combination, and this is some more mathematics about it, but I won't go into it. So the idea then is we have this theory of conscious agents, we have this logic. We'd like to now make predictions in space and time, because that's where you can test your theories. So how do we do this? Well, so what we've done is we start with the conscious agent network outside of space-time, and we discovered and published a way to categorize our conscious agent networks with the same decorated permutations that the physicists found categorized their positive geometries outside of space-time. We did that on purpose. Our idea is to start with these networks of conscious agents outside space-time, use the decorated permutations to map, that the physicists have found, to map our work onto theirs, onto their positive geometries. We have a dynamics, their stuff is static, so we'll be proposing that we're the dynamics behind the static obelisks that you found. This is what's really going on. You found the obelisks, but behind the obelisks, there's actually the dynamics of consciousness going on. That's the idea. And then the nice thing is, once we get that, then the physicists are doing the hard work of getting us from the positive geometries into space-time. So I don't have to do that. I'll let the physicists do that part. So that's the idea. We're going to shoehorn on what the physicists have done. We'll map to their positive geometries through the decorated permutations. They take us into space-time. So so I'm going to go through that quickly. So I'll just say at top level, and there's not time to really go into the mathematics. But when we do these connections and look at the connections between our Markovian dynamics and the decorated permutations that the physicists found, what we find is we can propose that particles in space-time are projections of the recurrent communicating classes of Markovian dynamics of consciousness. So, and just to illustrate, those colored boxes are there's 3 different recurrent communicating classes in that little Markov kernel that I'm showing up there. That's just, I'm not telling you the definition for time, but, and then we can actually talk about using this mathematics of consciousness, we can talk about when these particles are free, when they're bound, and when they're confined. So we can actually model that kind of thing in physics. And then we can look at things like, we can propose that, for example, that mass of particles in space-time is a projection of something called the entropy rate of these Markovian kernels of consciousness. So the momentum is a function of the number of states, spin of particles is a function of the determinant of these matrices, and distance in space-time is a function of something called commuting times of these matrices. So so the reason we could do this is we use the decorated permutations to tell us what part of our conscious agent Markov dynamics corresponds to particles in physics. And when we did that, the mathematics told us you have to look at the recurrent communicating classes, and that's what told us then to look at these things as the properties. So I said that whenever you have a theory, you can always try to find a deeper theory that explains the assumptions of the earlier theory, right? So here we are. We're saying that space-time is doomed, it's not fundamental, and I'm proposing that consciousness is more fundamental. So can we go back and explain some of the assumptions that space-time physics used? So Einstein, for example, when he gave us the theory of special relativity in 1905, said, I'm going to assume that the speed of light is the same for all observers. Every observer sees the same speed of light. He doesn't explain that, he assumes it. That's one of the assumptions of his theory. I believe that we can assume, so every theory assumes something and explains something. There's no theory of everything, as I said. So I think that we'll be able to explain why the speed of light is the same for all observers. The idea is that, again, I can't go into detail on this, but I'll just say it at top level. Mass, I said, is the projection of entropy rate. When the entropy rate is 0, you get the Markovian kernel with its called P there, it has all zeros and ones. So that's what, whenever you have entropy rate of 0, you'll have a Markov kernel that's like that, periodic kernels. And when the entropy rate is greater than 0, you have one like the one I call Q, where you have a bunch of numbers. So when you have the kernel that I call P, it turns out that you're going to have the fastest commuting times. And you'll always have anybody who gets that kernel will see the exact same commuting times. So what this means is that there is a speed limit that comes out of this theory. It comes out of the fact that each row effectively has to sum to 1, because these are probabilistic. And the fastest recurrent commuting times are going to be these entropy rates that are 0. So this actually explains why all observers see the same maximum speed, the speed of light, and also why objects that are massless are always perceived to be at the speed of light. So this falls right out of this. So we haven't published this yet, so I'm just telling you this is the paper we're writing up right now. I thought you might be interested in something that was new that hasn't been published yet. But what we're planning to do is to show that we can actually use this to then predict scattering amplitudes and also momentum distributions. So one thing we want to do is look inside, the atoms and the nucleus and see protons and neutrons, and you see like up and down quarks inside of a proton. We'd like to look at the momentum distributions and be able to use our model to predict the exact momentum distributions of quarks and gluons that physicists have found in scattering experiments. So we're trying to have a science of consciousness where consciousness is first, but it's not a hand wave. We're going to actually explain where the speed of light comes from, and we're going to try to explain exactly momentum distributions and so forth inside space-time. And if we can do this, then maybe scientists will start to take seriously the idea that consciousness might be fundamental. So we'll be looking at, I just mentioned, at the lowest resolution inside space and time, you get, inside the proton, you get what are called two up quarks and a down quark, the valence quarks. When you increase the spatial and temporal resolution, you get a lot of quark-antiquark pairs and a lot of gluons. And when you go to the highest spatial and temporal resolutions, what they call Bjorken X and Q squared, then all you see is a gluon C. So we're planning to run simulations. We've already run some prototype simulations which give us qualitatively this kind of thing. So we're going to run some real serious simulations. We're going to need a bigger computer to actually try to get exact matches with the momentum distributions. And these are some examples of momentum distributions that we'll try to match. If people want to see some of the math that we have published on this, we have a paper called Fusions of Consciousness, and if you just Google that, you can get the paper. It's free. So you can actually see where we use the decorated permutations and make some of these connections. So that paper is published. The trace logic is brand new, and this derivation of the speed of light is brand new, so we plan to publish that. So,
Too fast. Can you go back?
Oh, sure.
Sorry.
Sure.
Thank you.
So I guess I'll summarize as follows. Right now, the presumption is that physicalist theories of consciousness have the upper hand. They're the ones, most theorists are physicalists. What I'm proposing is that that's about to end, that consciousness is just the wrong problem for space-time because space-time is not fundamental. But space-time is the right problem for consciousness. I think we can start with a theory of consciousness and then boot up physics as a special case of consciousness. And the idea would be that what we call space-time is just one little headset that consciousness can use to interact with other consciousnesses. And it's not a terribly interesting one. Frankly, I think we got cheated. We're probably it's only 3 dimensions of space and 1 dimension of time. If you're a string theorist, maybe 11 dimensions. But why not have a 50 or 1,000 or 10,000 dimensional? Why not have much more? So I think our space-time is a fairly cheap model, not terribly interesting model. And what we'll be able to do now is to first start off and show that consciousness can boot up our cheap model, but then it can do much more fun stuff. So I'll stop with that.
About 5 minutes for questions. Can we get the mic on the questions?
Switch it on. Oh, there we are. Yeah, your matrix P, where all your probabilities add up to 1. If you look at Stephen Wolfram's model of the Rouliad, where the ultimate structure is given by the maximum possible extension of rules of computation, he proposes that you might have local variations in dimensions and therefore possibly local variations in the speed of light. Would that not suggest that you might have cases of that matrix where the probabilities don't add up to 1?
Well, that's a question I might ask him when we're going to be doing a podcast together in a couple weeks. So that'll be fun to ask him. So, but I'll say that Steve and I have very, very different points of view, I think, and I'm going to be checking this with Steve when we talk. So Stephen, he starts off with the Rouliad in this space of all these possible algorithms, and he finds out that he's looking for the part of that algorithm space that would correspond to what we call our physics. So I'm very interested to ask him, okay, if you're taking the Rouliad as fundamental, what's your theory of consciousness here? Are you saying that the Rouliad describes all the kinds of consciousnesses, or does consciousness only appear in certain worlds that come out of this Rouliad? So I'm going to be interested to ask him what he thinks about that.
I think that's actually a weakness of his theory because he's trying to develop an observer theory, but I think he makes some rather naive assumptions.
That's right. In fact, I plan to show him my observer theory, the one I just showed today. The trace is the observer. because he understands that you can't just have an objective observer. He does understand that, right? The Newtonian observer is objective. Our observer with the trace is saying, you only observe that of which you are an organic component. When you observe something, you are an integral part of the thing that you're observing. You're not the dispassionate objective observer. So it's a big deal. So he might agree with me philosophically, but I'll see if he agrees with me technically as well. It'll be fun.
Let's go over to this side.
Yeah, Don, thank you very much. Very interesting. So just to clarify, the neuronal microtubule theory is actually the OR theory, which depends on OR to create consciousness, which comes from quantum states which collapse. So it's the superposition going to classical that gives you consciousness. So it's not actually a physicalist theory. It does come from space-time, which you're trying to get rid of. I suspect, I don't know, that Roger might be okay with saying something deeper underneath it, as long as it might do something like have curvature and separations, which then anneal or collapse back to give you consciousness. Because one thing, you're kind of, I mean, I'd like to see consciousness in reality, and it seems to me you're taking it out of reality, but maybe you disagree with that.
Okay, well, so that last point is an important one. So I'm saying that what we call physical reality is just a little headset inside of consciousness. So we tend to think of ourselves as little tiny 150-pound entities inside of a big space-time. And I'm saying, turn that around. You know, all of space-time that you thought was this huge thing is just a little trivial headset inside your consciousness. So this is, it makes you quite a bit more interesting than perhaps you thought.
Impossible.
I think we can do one more question.
Can I just say one more thing?
Sure.
We're just talking about one frequency also. And in our theory, you can go down faster, 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 all the way to the Planck time. And so that's a little bit more than one little speck of reality.
Right. But it stops at 10 to the minus 33 centimeters, and
Well,
the game's over, right?
Well, like I said, Roger might be okay with going deeper if there is such a thing, but I'll leave it there. Thank you very much.
Thank you very much.
Fascinating.
All right, let's do one more question.
Thank you. Thank you so much. I have a question about the definition of the communicating class. When you say communicating class, what do you mean by that? What is the nature of it? And also, when you say transition, I think by definition, transition assumes time. And you said space-time
okay.
is doomed, so yeah.
Great question. So this is a technical question now, so I'm going to be a little technical. So in a Markovian matrix, a recurrent communicating class is a set of states where from any one state you can get to any other state with positive probability and back. Okay, so that's a communicating class. On the issue of time, which is an important one, in a Markov dynamics, you can have a dynamics in which it's stationary. So the entropy at every step is the same. It's easy to do. And that's probably what we would use to model consciousness. But it's a theorem, a very simple theorem, three-line proof, that if you take a projection of that dynamics, using conditional probability, for example, you'll get a new dynamics, which is a projection of the other dynamics. So you see a new dynamics, and that dynamics will necessarily have increasing entropy. So it will have an arrow of time. So what we propose, what we're going to propose, is that the realm of consciousness is timeless in the sense that there is no increasing entropy. And what we see inside space-time of an arrow of time due to the entropy is entirely an artifact of the projection. And so I talked about evolution by natural selection. And let me say first, I love evolution by natural selection. Most of my book is about it. So I am not putting evolution by natural selection down. It's a wonderful theory. If you're going to look at biology inside space-time, use Darwin. Having said that, every aspect of Darwin's theory is an artifact of the projection. Time is the fundamental limited resource in evolution. If you don't breathe in time, you die. If you don't eat in time, you die. If you don't mate in time, you don't reproduce. Time is the fundamental limited resource. And that limited resource is entirely an artifact of projection. It's not a fundamental feature of the truth beyond space-time. So we could have a dynamics of consciousness in which there is no lack of resources. There's all cooperation. Everybody loves each other. You take a projection of it, it looks like nature, red, and tooth and claw from the projection. All an artifact of the loss of information.
Thank you very much. Let's thank our speaker one more time.
I'll grab mine.
All right, our next speaker is a long-term attendee of the Science of Consciousness Conference. I don't know how many books he's written, but I know it's approaching 100, probably. One I read at the recommendation of a dear friend was You Are the Universe, which has really stuck with me. I'm still grappling with it, but the idea of the multiverse inside each one of us is a universe, and the multiverse is all of us is something that keeps resonating with me. I'm super excited to welcome Deepak Chopra to the stage.
Do I get a microphone like Don has? Okay, so you can hear me, right? I'll start by saying that every time I listen to Don, where are you? I learn something new every time I listen, and I've been struggling to keep pace with your thought process. For anyone who's interested in this struggle of understanding the cutting-edge science and math and physics and neuroscience that Don Hoffman is doing, we have 20 conversations on YouTube. If you go to Chopra Well, the Chopra Well, there are 20 plus conversations on YouTube about exactly what he's saying. And of some of the things that he said seem totally abstract to you, you might find some clarity because I constantly want to understand him in layman's terms. And where I'm going to go with you today is try to reconcile the scientific worldview that Don is espousing with a spiritual worldview that is part of my spiritual inheritance. So I'm not a scientist, I'm a physician. I did train in neurochemistry and neuroscience, but that's not my field. My field has been neuroendocrinology, and I've, over the years, kind of dabbled in these conversations with people like Don Hoffman, with people like Stuart Hameroff, and Roger Chalmers. And so I'm going to try and reconcile the worldviews that science is proposing and where Don is going about the case against reality with a spiritual worldview that comes from ancient wisdom traditions like Vedanta and Kashmir Shaivism and Buddhist philosophies. So as you heard, the two most open questions in science are the following: what is the universe made of, and what is the biological basis of consciousness? And I think if you follow Don, then you will see that these are wrong questions. Basically, these questions will never be answered because they might be the wrong questions. And we assume that the universe is made of atoms and particles and force fields and gravity. We assume that, but we also know that the visible universe, which is 2 trillion galaxies, according to the James Webb Telescope now, 2 trillion galaxies, 700 sextillion stars, and uncountable trillions of planets, probably 60 billion habitable planets just in the Milky Way galaxy. So that's the current science. You can go to the internet and check it out. 60 billion habitable planets in the Milky Way galaxy, 700 sextillion stars, and 2 trillion galaxies. So if we buy that science, then our planet is not even a speck, a grain of sand on all the beaches of the world. Not even one grain of sand. And on this grain of sand, we have a species called Homo sapiens that's trying to figure out reality. And that seems a little bit of hubris to me, actually. And I love where Don is going, but I have to say that even, and Don will agree, that even what he's saying is a model of reality. It's not what we call reality, but a story about reality. And it's an emerging story about reality. And if you look at what deep historians have to say, you will find the following story about how we created these models of reality. So it's, according to deep history, about 40,000 years ago, or 50,000, or 60,000, take a few thousand years, around that figure, 40,000 years, there were 8 different types of human beings, 8 different human species. We call ourselves Homo sapiens, which means the wise ones, and we were humble enough to give ourselves that name. And then we gave names to other species, Neanderthals, Homo erectus, etc., etc. And according to deep historians, all homonyms, as we can call them, had a language, just like all animals have language. And the language was only about 3 things: mating calls, food calls, and danger calls, because that's how we survive. Sexual mating, danger, and food. And then one species, we, Homo sapiens, we separated from all the other species, including the other homonyms, because we created the language for stories. And then we embedded ourselves in those stories. The first stories, the most dominant stories of humankind, are gossip. And they're still the most dominating stories of humanity. All we do is go on the internet, see the news today. It's all gossip. But then we created other stories. We created the story called money, which rules the world. There was no such thing. We created a story about God, cultural mythology. We created stories that we actually take for granted, like Greenwich Mean Time. It's not Botswana Mean Time, it's Greenwich Mean Time. We created a story called Latitude and Longitude. And we are so embedded in the story that we never question the story. So those stories created models of reality, and those models ultimately became scientific models, but scientific models are stories in our current understanding of what we think reality is. So what is the universe made of? Assumes that the universe is made of something called matter, which resides in the theater of space-time and causality. That's how we start. And then we have a problem. What is the biological basis of consciousness? Because then we ask ourselves, how do force fields, atoms, molecules, gravity create consciousness? What's the biological basis of consciousness? When in fact, that only accounts for 0.01% of the visible universe. As you know, that right now, 70% of the universe is considered to be dark energy. We have no idea what it is. It's not mass is equal to energy. It's the opposite of gravity, if we believe in dark energy. 70%. Of the remaining 30% of the universe, 27% of the universe is dark matter, and it's invisible. It's probably not even atomic, and because you and I are made of atoms, we can't interact with it. But we call it matter, nevertheless, because it accounts for most of the gravity in the universe. And if it wasn't for dark matter, planets would spiral off and disappear into intergalactic space. You and I wouldn't be there. So only 3% of the universe is known to be atomic. Only 3%. Of that, 99.999% is invisible interstellar dust. Invisible interstellar dust. So the visible universe, 2 trillion galaxies, 700 sextillion stars, uncountable trillions of planets, maybe 60 billion habitable planets in the Milky Way galaxy, is 0.01% of what apparently is out there. 0.01% of the universe, visible universe, is atomic, 0.01%. But as you know, according to our current science, atoms are made of particles, and particles have a dual nature. They only show up when you measure them, and when you don't measure them, they disappear into mathematical space, Hilbert space, where you ask them, what are the waves that create matter made of? Because we assume everything is made of something. So, sound waves are made of the vibration of air molecules, and the waves that go to your brain as photons appear as this. But that's only 0.01%. And what are the waves that create particles made of? The only answer you'll get is they're made of possibilities. And if you ask, where do these possibilities exist? They exist in Hilbert space. What is Hilbert space? It's a mathematical space. So what is the universe made of? We don't know. What is the biological basis of consciousness? We don't know. Maybe these are wrong questions, because even biology is an experience in consciousness. How do you know you have a biology? You experience it. You see it, you touch it, you taste it, you smell it, you think about it, and then you say, this is my body. And so biology is not the basis of consciousness, perhaps. Consciousness is what gives us the model that we call biology. So science works like this. Science asks questions, how do things work? What's going on? It starts with theory. And the theory is based on, as Don said, assumption. In science, the assumption is matter is the ontological primitive of the universe. It's where we start. And then you experiment, you do observations, you validate, and that's good science. On the other hand, what we call spirituality is also a kind of science. It starts with the question, who am I? Who or what is experiencing the world? Why is there existence? And what do we even mean by it? Why do we exist? And so this conversation is becoming very dominant now in the scientific circles. These are some of the new issues, cover articles in the New Scientist and some in the Scientific American, which are questioning how did we learn to speak? How did we learn to create models? What are the secrets of the mind? Is consciousness fundamental to the universe? What is reality? The more we look at it, the more unreal it seems. Is your body thinking, or is it just your brain thinking in English with an Indian accent? How big is infinity? Are we actually looking at evolution only in terms of survival of the species? Is it hiding the truth, which is what Don is suggesting with this mathematics of fitness beats truth? And is consciousness behind evolution? Is the universe conscious? What is the heart plot, the heart of reality? So I'm just going to show you some of the differences between how we approach science and how we approach the understanding of consciousness in some of the wisdom traditions. So science is based on the idea that matter is the ontological primitive. You start with matter. Spirituality, at least in the Eastern wisdom traditions, you start with consciousness. It is the starting point of existence. Science is based on subject-object split. I'm the observer, you are the observed. And spirituality, at least in the wisdom traditions, subject and object are entangled experiences of a deeper reality. In science, we assume matter produces mind, so we have the hard problem of consciousness. In spirituality, the wisdom traditions, mind and matter, brain, body, and the world are complementary activities of awareness, awareness being consciousness, and awareness modifies itself as both cognition and perception. In science, we say reality is observer-dependent, although reality is observer-independent, although relativity and quantum mechanics question that. In spirituality, reality includes the observer. Observer is an expression of the reality being observed, and vice versa. In science, we believe in local realism until you question it, which you are questioning now. Local realism is the theater of space-time and causality. In spirituality, the picture of the world corresponds to the biological organisms that goes with it or is entangled with it. The biological organism and its corresponding world picture perception are complementarities. In other words, consistent with what you're saying, we are conscious agents that are species-specific, projecting a species-specific experience of what we call reality. And the theater of space-time and causality is a simulation or a projection or an illusion or a vibration in non-local awareness. And awareness is non-local. Now, you know, if you really understand this, this is a mind-boggling idea. Because if I asked you, where is this experience happening? Where is this experience happening right now? Where is the experience of seeing happening for you? Where is the experience of seeing happening for you? Is it happening in your brain? Well, there's no color in your brain. There's no Deepak in your brain. There's no theater. All there is electrochemistry. So where is this experience happening of seeing? Where is the experience of sound happening right now? There's no sound in your brain. All that goes to your brain is an action potential. And then there's neurochemistry, but you're listening to me. Where is that happening? Where is any experience happening? I think the logical answer is, it's happening in consciousness. Where else could it happen? There's no experience in the brain. Stuart will tell you, it will take a knife and put it through the brain, you don't even feel pain. There's no subjective experience in pain. Of pain, there's no subjective experience of any kind in the brain. So where is experience happening? It's happening in consciousness or awareness, synonymously. And where is this awareness? Well, we can't see it. We can't see it because it's what is seeing. And we can't experience it directly because it doesn't have a form. And because it doesn't have a form, it doesn't have a border. And if it doesn't have a border, then it's infinite, and it's timeless, and it's spaceless, and it's without cause, and it's fundamental, and it's irreducible, and it is what is modifying itself into this network of conscious agents which are projecting their species-specific universes, and there are infinite of them. So this is a mind-boggling idea. This experience you're happening right now is being processed outside of space-time. This experience you're experiencing right this moment is being processed outside of space-time. And I think Don would agree with that. Do you? Yes. Yeah, so there you are. Okay, so we go some of the similarities between science and spirituality is matter at microscopic and ultramicroscopic levels is basically composed of invisible particles and force fields, gravity, electromagnetism, and spirituality says reality has subtler levels of existence in the form of mind, intellect, and ego, which are also fluctuations of conscious agents, And elementary particles are impermanent appearances in the quantum field as determined by the uncertainty principle, but so are all experiences. And we experience only 4 things: sensations or sense perceptions, images, feelings, and thoughts. That's all we experience. Right now, you're experiencing sound sensations, visual sensations, auditory sensations, and basically you're creating models out of it. If you want to think of an acronym, SIFT, sensations, images, feelings, and thoughts, which are fluctuations of species-specific conscious agents. Science says the world is made of objects, and then spirituality says the world is made of experiences. So if you just substitute the word object with the word experience, so substitute this word, microphone, as an object with the word experience, what is the experience? It's sensations. That's all it is. It's sensations, images, feelings, and thoughts. So substitute the word object for experience and ask yourself, where is experience happening? Outside space and time. So in science right now, quantum reality is fundamental, and in spirituality, the quantum field, as described by science, is the symbolic representation of the consciousness field. So what we call the quantum field is the symbolic objective representation of the consciousness field. It is conceived, constructed, governed, and comes into existence in the consciousness field. In quantum field, fluctuations of impermanent virtual particles determined by the uncertainty principle, the qualia field, fluctuations of sensations, images, feelings, and thoughts, also determined by the uncertainty principle. Quantum field, superposition of particles, qualia field, superposition of experiences. Entanglement, non-local correlation, same ideas. Source of the physical universe, the quantum field, and source of the experience of the physical universe, the qualia field. Qualia field would be the consciousness field. I'm glad you selected just 2 things, and those are enough: qualia and activation, right? Those are basically the most fundamental. Then we answer those 2 questions, you answer all the other questions. So again, I'm not going to go into all this, but in the absence of the arrow of time, when you get to Planck scale, there's no time. Point 10 to the power of minus 33 seconds, Planck time disappears. 10 to the minus 43 seconds, time disappears, and 10 to the minus 43 on the Planck scale, also, I believe time disappears. There's no time at that level, right? Okay. So, therefore, you can see the similarities between quantum mechanics and what we might call quantum consciousness. Wave-particle duality in consciousness, mental events show wave-like features, and in these Eastern wisdom traditions, by the way, there are 4 stages of how a thought appears. So if I ask you right now, just close your eyes for a second and ask yourself the question, I wonder what my next thought is going to be. And wait for it. Now open your eyes. Did you notice when you wait for a thought, it takes its time? So there are 4 stages of thought, according to the consciousness theories. First is called para. Para means it exists in superposition with all other thoughts. The second stage is called pashyanti, which means it starts to appear as a cloud of probabilities. The third stage is called madhyama. You now hear it as internal dialogue, and then you speak, you collapse the wave function. You collapse the wave function in consciousness, that we call thought. So all mental events exist in superposition and entanglement as sensations, images, feelings, and thoughts. Think of your mother right now. As soon as you think of her, do you see an image? Can you hear her voice? Can you actually feel the sensation of touching her skin and even the smell of her skin? all those are entangled events in consciousness. All you have to do is think of one thing and everything shows up. Sensations, images, feelings, and thoughts as expressions of that. So again, without going into details, I'm happy to make my slides available to you, but there are very good similarities in the understanding of quantum mechanics and the understanding of what I will call quantum consciousness at this moment. So in non-dual traditions, quantum entanglement is not considered strange. It is known as non-local correlation or synchronicity, which is happening outside of space-time. Our current science is based on a philosophy in science called naive realism. This is not a condescending word. It is an actual word in science, in the philosophy of science. Naive realism. So according to this, and I think Don would agree, that Einstein was a naive realist because he assumed that matter is the ontological primitive of the universe. In naive realism, we also believe the universe is observer independent. Well, how do you prove that? How do you prove an observer independent universe? You only know it through observation. Of course, it's also based on the idea of subject-object split, which is obviously artificial. And it is also based, naive realism, is that the picture of the perception of the world is the human look of it, not of other conscious agents. What does the world look like to an insect with 100 eyes? What is the experience of the world to a bat that only knows the echo of ultrasound? What is the experience of the world to a whale that communicates through ultrasonic? So what we call the physical world is the human experience of it. And that is assumed to be the objective world. That's obviously naive realism. So I'll skip this, and I'll skip this, and I'll just share with you that as we explore through spiritual practice, through reflection, through mindfulness, through transcendence, through inquiry, do experiments in consciousness, these are the 7 breakthroughs that happen. There's a shift in identity. You're a non-local being having a local experience, number 1. Number 2, brain and mind are complementarities of a deeper reality beyond space and time. Number 3, existence is self-aware. Number 4, reality has no form. Number 5, the experiencer as a conscious agent being outside of space-time is eternal. Number 6, infinity can never be compromised, because whatever you do with infinity, and you are the expert, infinity remains. Infinity divided by infinity is infinity, multiplied by infinity is infinity, subtracted infinity from infinity is infinity. And this world that we experience is a magic show, and the conscious agent is the magician. And actually, this has a long tradition in Kashmir Shaivism and in Buddhist traditions. They say the waking state is a lucid dream in a vivid now. The dream state is closer to fundamental reality. The deep sleep state is a non-local state. And then beyond that is a glimpse of the conscious agent. And when the conscious agent becomes dominant, then there's something called cosmic consciousness, which is local and non-local at the same time. Local as the appearance and non-local as the reality. And then there's something called divine consciousness, which is that you experience everything in its non-local nature. And then finally, unity consciousness, where all subject-object split totally disappears. So these are some of the milestones that we are studying in people who are exploring reality subjectively, not through science, but through spiritual practices, including mindful awareness of the body, mindful awareness of mental space, mindful awareness of the perceptual space that we all have, and mindful awareness of our relationship with what we call the universe. And these milestones are being documented right now. We have a paper published on this right now And there are shifts in sense of self to non-locality, a change in emotions from fear to love, a shift in perception in which we see things as entangled and not as locally real, a shift in memory, use memories but are not victimized by memories, insight, intuition, vision, creativity, which cannot be answered through any physicalist philosophy or model. And ultimately, a sense of ecstasy and transcendence, loss of personal agency from me to we to one. And the formula here being 0 is equal to infinity is equal to 1, and a loss of fear to death, because death happens to conscious experiences, not to consciousness itself. And something that is now being talked about a lot is the direct method. Direct method is you look at objects, any object, you reframe it as an experience, then you ask yourself, what is the experience? And you find out it's a combination of sensations, basically. And then you ask yourself, what are sensations? They are consciousness modifying itself into sensations. That's why we call ourselves sentient beings. And everything that is alive is sentient. And this goes beyond panpsychism. Because if you understand this philosophy or this model, then only consciousness is conscious. Human beings are not conscious, animals are not conscious, plants are not conscious, microbes are not conscious. Only consciousness is conscious as that experience. Consciousness is conscious of itself as the experience we call the human process. Consciousness is conscious of itself as what we call this animal. What we call, a giraffe doesn't know it's called a giraffe. That's a model in human consciousness. So when we go that, this is what is one of my favorite slides. It says, we are led to believe a lie when we see with and not through the eye that was born in a night to perish in a night while the soul slept in beams of light. So when we look through the conditioned mind, we see this theater of space-time and causality. But when we transcend the conditioned mind, we see reality as it is. Formless, infinite, unbounded, transcendent, beyond space and time. I know I've shown these pictures to Stuart many years ago. So how many of you see a man riding a horse? How many of you see an old man with a beard? Well, those images are in superposition till you decide which one. There are no images, there are only colors. And colors are not a feature of the physical world. Anybody will tell you that there's no color in the physical world. Only photons, and photons have no color. So where is color? As a qualia experience, it's a modification of consciousness. And so too, you see all these images in superposition. You can choose what image you choose to see, because actually all they are is a bunch of colors which are modifications called qualia in your own consciousness. Whether you see a mountain and a range, a mountain range and backdrop of sky, or you see a woman with locks, or you see horses, is all superposition of qualia experiences in consciousness. There's no dragon, there's no face. There's only colors. And colors are qualia, modifications of consciousness. That face that you see is not on the screen. There's no face, and there's no animals. There are only colors, qualia, in superposition. And so what is that reality that Don is trying to explain to us? It's this meta-reality, a field of infinite possibilities, formless, without cause, irreducible, infinite, fundamental, infinitely creative, actually, unfolds through non-local correlation, the source of attention and intention. That's why I liked your two choices, qualia and attention or activation, free of modifications of experience, self-organizing, self-regulating, self-evolving, and rooted in the sense I am. So I'll stop there. with 1 minute to go, and happy to answer any questions.
Hello. Deepak, isn't there a logical paradox in stating in the spiritual practices that space-time and causality are illusion, simulation, and yet all of us, all scientists with whatever theories, are standing in this illusion and claiming their theory to be true? How is that possible?
I think if we try to understand reality, it is full of paradox, it is full of contradiction, and it is full of ambiguity. That's the only answer I can give you.
Okay.
Go ahead.
Deepak, Donald, thank you for your information. So I have a question. In order for us to live consciousness, we at least have to have a body, a mind, and a soul. My question is, where do you live, or what your thoughts are in consciousness and in related to the mind?
Well, according to the theory that I've just suggested, there is only awareness, and you are awareness. You and the universe are awareness. It modifies itself as the experience we call mind, intellect, and ego. It modifies itself as the five senses. It modifies itself as the five motor actions. And then through that, we experience the theater of space-time and causality. There's one phrase in the Upanishads, I am the field and I'm the knower of the field. So the field knows itself as mind, intellect, ego, senses, perception, cognition, body, and the physical world.
Okay, thank you.
Go to the other side of the room.
Thank you. So I have been rereading Brian Masumi. He's a philosopher and critical theorist. About 10 years ago, he wrote a book about animals and politics. And he made a very convincing argument that animal play, creativity, and sympathy were sort of adaptive and fundamental to evolution. And so I think it resonates with your cosmology as we had it up here, but do you have any thoughts about animals?
Yes, animals don't create models.
Sorry, animals are what?
Animals don't create models of reality. They just experience it as qualia, basically. And therefore, they seem to be more connected to the source. We, by creating models of reality, we confuse ourselves.
Okay, thank
So the more we know, the more the unknown looms, and the unknowable looms even further. So what I'm saying right now, whatever reality is, it cannot be anything that is conceivable or perceivable. Whatever reality is, it cannot be anything that is perceivable or conceivable. You have to go to the source of perception and conception, to the conscious agents, which are part of the matrix of experience.
Daniel?
Thank you for your contributions, Dr. Chopra. You started off your presentation with describing language as being divided in three: mating, food, and danger. And then in the search for spirituality, there's often there's the guards around the temple. Okay, there's a defensive response around the temple. And the word in English, the word sacred is related to the English word sacrum, lower body of physiology. So I'm curious, in many traditions around the planet, there's a tendency for the seekers and the philosophers and the explorers to be of the male genetics, men exploring. And so I'm curious what might be the framework, or how would you contribute to what if we were to, in addition to using our brains in the inquiry process, to look at the contribution of the reproductive organs, like the womb, okay? Looking at the high tantras, for example, okay, like the white tantras, and looking at what is consciousness that happened down here in the lower parts of the body versus the history of like the last several hundred years, at least in Euro-American, of kind of bringing awareness up to the brain and the central nervous system.
I struggle to answer your question, other than I can say that the brain, the human brain, or what we call the human brain, is the most complex field of awareness. And so are all the other organs in your body. They are fields of awareness that give you certain experiences in awareness, and they're all entangled with each other. So think of your brain as a complex field of awareness, entanglement, non-local correlation, but all the other organs, you know, the chakras, basically, as in Eastern system, they're junction points between consciousness and a particular experience in biology.
Yeah, I think
Symbolic.
looking at that as like, so the whole body arrives from our genetics, from our germ cells. You know, if it wasn't for our reproductive organs, the brain wouldn't exist. So I think there's a good conversation there over time. Thank you very much.
Thank you.
Let's do one more question.
Okay, Deepak, it's always a pleasure to listen to you. I always enjoy it. I have a question for you and Don, and it's very likely my misunderstanding of the concept. So I clearly need to go back and watch the 20 episodes. The question is, when you speak about the conscious agent, you say agent. When Don talks about it, he says conscious agents. And some of them seem to be sub-agents that are following one agent. So I was just wondering if you could clarify, is there one agent in this theory, or are there like multiple agents?
I think they're differentiated from one. Not separate, differentiated from one. Don? Don says yes.
Okay.
All right, thank you so much. Let's thank our speaker one more time. Okay, our final speaker for the afternoon plenary is Paavo Pylkkänen, a mind-body philosopher from the University of Helsinki.
All right, thank you. Okay, thank you very much. And okay. All right, so as my title, I had real consciousness in a real world, and I thought the real consciousness is maybe, it's toward illusionism, and perhaps real world is then a contrast in some ideas in the session, though perhaps not a terribly strong contrast. And then I've added also interactionist monism as a view that I'm trying to develop here. Or we could call it also interactionist dual aspect monism. And the question here is that, and monism means, you know, there is one thing that exists as opposed to dualism, right? Reality is one substance, for example. So anyway, can we have a monism where there is room for both mental and physical aspects? And can we have a two-way traffic between these aspects? And so this view, interactions dual aspect monism, which is inspired by the quantum physicist David Bohm's ideas, suggests that we can. But this is not necessarily Bohm's view, but it's something that I've kind of developed from it. And the naive idea here is that reality has manifest, or physical, and subtle, or mental levels which interact with information acting as a bridge between the levels at each stage. So this would be this is very much a Bohmian idea here. So the question here is whether information could be a kind of bridge over the explanatory gap, or the missing link between mind and matter. And we may, we'll get to consciousness later on. Now, why would we want to have such a view? And I've just listed some of the other views we have. Well, there's interactionist substance dualism, which is intuitively, of course, may feel right. I mean, in some ways, Descartes' the dualism has much that is intuitively interesting, and even philosophically still interesting, the way he kind of gave attention to how different consciousness and the physical world seem from each other. But if we postulate consciousness and matter as two separate substances, then it is difficult to understand how they could really interact. A weaker version of dualism would be property dualism, where we think that mental properties are non-physical, but they're properties of physical processes. And this typically leads to epiphenomenalism, so they would be mental would be inefficacious. Of course, there could be a physicalism, let's just say it's all matter. And the kind of physicalism that we have on offer in modern philosophy of mind this is a bit taking it from the philosophers Leidman and Ross. You could say that it presupposes implicitly an old-fashioned mechanical, they call it A-level chemistry view of the physical world, which cannot do justice to obvious features of mental states and conscious experience. So I'm not in principle against physicalism, but I think physicalism should really come to the 21st century or even to 20th century physics. Some of it does, but a lot of it doesn't, okay? I put obvious in square quotes because, of course, we can always question what is obvious. We can question our intuitions, but still I personally don't want to believe in the view that I somehow feel it's obviously not correct. So, but if you can convince me otherwise, then maybe I'll change my mind. Anyway, so the same thing, with idealism. I mean, of course, it's kind of interesting. It's very interesting that it's been discussed a lot. It has its pull. I mean, it's tempting in its own way. But we could say that it cannot do justice to the obvious fact that the universe has a material aspect which exists independently of the human mind. And so, and then there's, of course, panpsychism, but then we can ask, is it really plausible that elementary particles are conscious? I mean, I have been flirting a lot with the idea that, the Bohmian idea that the electron has this quantum field. I'm going to talk about that a little bit, which is kind of a primitive mind-like quality, but still not all, I'm kind of not keen to go all the way to this kind of stronger form of panpsychism. And I guess Bohm himself wasn't either. But it's of course hard to tell what people think in their secret minds, right? Anyway, functionalism I think is better in the sense that I think it's a very general scheme. You could apply that even to res cogitans, if you like, to a mental substance. So, but I think the way functionalism is being used is combined with this usual old-fashioned physicalism. It's a very mechanistic picture of the physical world. As John Searle would say, it just leaves out the mind. Otherwise, it's a brilliant theory of mind, but it so happens that it typically leaves out consciousness, it leaves out the mind. So one has to be careful with functionalism. Now, of course, there's illusionism, but there we could say, well, that just denies the obvious fact that phenomenal properties exist. Otherwise, it's very interesting to question everything like, Dennett, Keith Frankis. But of course, even if you realize you can question all these things, it doesn't follow that you therefore must believe in where you end up if it's obviously wrong. Otherwise, or else you have to convince people that it's not obviously wrong. Okay, but this is just a little bit, because I'm going to take you then to a different view, and this is just to motivate it, because so you bear with me. And of course here, the person here is David Bohm. Mario Bunge once called him the David who faced the Goliath of quantum indeterminacy. And that goes back to 1952, when Bohm published the first consistent, realistic, and deterministic interpretation of quantum mechanics. And so anyway, I used to know and study with Bohm and work with him a little bit in the 80s and 90s, and the stuff here is partly actually the old ideas we were discussing back then, which still kind of don't leave me alone, so to speak, or haunt me. So ideas choose people, and so I haven't yet been moved on from all of these things. Anyway, so as many of you know, and I mentioned already, Bohm proposed this causal interactionist scheme for quantum theory known as the pilot wave theory. And here we say that the electron is a particle always accompanied by a new type of field, or pilot wave described by the wave function. So this is different from, for example, Copenhagen, where some people say, well, electron is sometimes a particle, sometimes a wave, depending on the context, and you might have a collapse wave function. explain the measurement situation. But in this picture, you don't need a collapse. You just need to assume this model where you have a particle and field, where the field is then guiding the particle. And so there's a very suggestive analogy here, because we say, well, just as the pilot wave guides the particle, so mental states guide the physical body. I mean, it's just an analogy, but there's, this is, I think, even great physicists, philosophers of physics like Harvey Brown, they're really, when they realize this thing, they're really struck that there's some, this is interesting. If this is the way, if this model is correct, and if our reality is like that, it is pretty cool that even in the fairly fundamental level of quantum mechanics, we have this kind of analogy to ourselves. And of course, Bohm later on, like in the 70s, 80s, he developed his original 52 model and started arguing that these pilot waves are actually, they're literally informing the energy of the particle rather than pushing and pulling it in a mechanical fashion like water waves would do. So that's again showing that in this sense, quantum mechanics is different from classical physics or classical field theory. And so you could say that already at the quantum level, we have entities which have two aspects, a thought-like wave guiding a rock-like particle. So that, you could bring that also into your metaphysics as a kind of feature of those entities. And so what's happening with this information? We say that these pilot waves, well, they carry information about the environment of the particle. For example, slits. So the two-slit experiment. And the thing to realize that this information that's carried by these pilot waves, it's information for the electron. It's not information for us. So this just to understand how we, because we use the word information in so many different ways. So here, this is to understand the Bohm model, one has to really understand these things. And there's an analogy because if you think of radar waves guiding a ship, they would carry information about the environment, and then they would inform the energy of the ship. They're not pushing and pulling the ship, and this information is guiding or instructing the movement of the ship. It's for the ship, it's not for us. And it goes to the computer or whatever system they have in the autopilot mechanisms. But we can see this also in biology. I mean, there are many, many ways in biology where you can see information acting and guiding. The most familiar to us is maybe the way the DNA molecule, it's a code or language, and it's guiding protein construction. But even, I'm actually reading this lovely book by, I think it's Siddhartha Mukherjee, called The Song of the Cell, and there's fantastically many examples of how information acts in biological systems and cells. So of course now we might worry, well, what about us? Is there nothing for us? No, well, don't worry. When we're reading a map, that's information for us. So that's for us. And of course, books and all. There's a lot of information that there's for us, but we have to realize that not everything is all the time. So we have to see how. So we call this objective and active information. We say information is objective in the sense that it's an objective commodity that exists in the world independently of the human mind. And it also typically makes things happen. It is active. It makes a difference. It's like information, it's a difference that makes a difference. And so that's true. And here is just a schematic picture of the Bohmian model. This is from Basil Hiley. And this will show you actually just a two-slit experiment. So the particles are coming from the left. If it was classical physics, they would just go in straight lines. But because quantum mechanics operates at this situation, we get an extra force. On the right, you can see the potential, which you can think of as a mountain. So that's why this is one nice way of explaining the two-slit experiment. So this would be the selling point for the Bohm theory, that it actually does give you an intelligible explanation of what happens. Then there are some things you could criticize it, so every interpretation of quantum mechanics has problems with it. But this is the beautiful, if you're looking for understanding and explaining what happens in the quantum mechanics, then the Bohm theory is valuable, even though it may not be the literal final truth of what's happening there. It maybe tells you what might be going on there. And the interesting thing here is the quantum potential, where you can see that the R is the size of this field that I've been talking about, but this Q depends only on the second spatial derivative, so it's the form, and that's how Bohm got the idea that it's information that's operating here rather than waves in a mechanical fashion. But moving on, so as some of you know, and of course I've discussed these things before, Bohm tried to understand the relation of mind and matter in this pilot wave framework. And so thinking about the mind, we could say that it's typical of mental processes that we can make a meta-mental step. That is, we can think about objects, but we can also think about our thinking in an extending hierarchy. So there are hierarchically organized levels of information in the human mind. But then when you think about matter, Bohm, he claimed that it's natural mathematical to extend the pilot wave theory. So not only does the pilot wave guide the particle, there can be a super pilot wave guiding the first order wave, and so on in an extendable hierarchy. And so now we have two hierarchies of levels of information. One is for mind and one for matter. And so is this like a dualism? And in a way then to bring these together, Bohm suggested that these are the same hierarchy. This is back in 1990. And so here's a nice quotation where he would say that that which we experience as mind in its movement through various levels of subtlety will in a natural way ultimately move the body by reaching the level of the quantum potential and of the dance of the particles. There is no unbridgeable gap of or barrier between any of these levels. Rather, at each stage, some kind of information is the bridge. This implies that the quantum potential acting on atomic particles, for example, represents only one stage in the process. So notice one is not reducing mind to quantum level here, because remember we have this hierarchy of levels. But we need the quantum level to make, the move stuff, move the molecules or, influence the fields, for example, in the brain. And in that sense, this is a quantum, Bohm had a kind of quantum mind model, which is in some way similar to the Penrose and Hameroff picture. And notice also that here, if the higher levels of information can influence this quantum potential, this means that the laws of quantum mechanics will break down in that situation. And of course, that could then give some worries, but the interesting, and philosophers especially get extremely afraid when they see anything like this being said. You could worry about energy conservation, things like that. But the interesting thing is that physicists like Bohm and Penrose, they are not so worried about if their model would violate quantum mechanics. I think both of them probably sometimes wondered, they're puzzled why everybody believes in a certain theory in such a strong way. But okay, I just mentioned that as just to pay attention that in some ways wild things are happening here. Okay, but still we have a sense in which we are not reducing mind to brute matter or even to the quantum level, but we are kind of allowing mind to exist in these higher levels. So, do we have here something we could call a bridge over troubled philosophical waters? Because in this view, we understand the relation of mind and body in terms of hierarchical levels, ranging from manifest to subtle. The claim is that there is no unbridgeable gap or barrier between any of these levels. We could ask, well, why? Well, because at each stage, some kind of information is the bridge. So the question is, can information truly help us to cross this explanatory gap? Of course, explanatory gap in philosophy is also between consciousness and matter. But I think even if we can get a smooth two-way traffic between the mental and the physical, we are at least closer to resolving the explanatory gap with consciousness. But I think it's still worth going back. I think, with Bohm, if you're trying to read, he wrote different schemes, different papers, and slightly different terminology. And so what I've struggled to do for today, to look at another paper by Bohm called Soma, Significance and the Activity and Meaning, which I think in some ways may give a better understanding of this picture. And this was in the early 80s, and I remember reading the paper like, I don't know, 83 or something like that. It's very exciting. But then there we go. I think this was also published in The Essential David Bohm. So what's Soma's significance? I mean, as you may know, David Bohm, he liked to, come up with new terms to describe, implicate order, Soma significance, and so, of course, sometimes it takes a bit of time to get a feeling for these terms. But anyway, the naive idea here is that Soma, which is the physical, and significance, which is like meaning, but also the mental, are two aspects of reality. So here this is somewhat similar to even the previous talks, like with Deepak, and that we get the feeling. So reality is not purely material, but it has this dual aspect feature in it. And I think Friday morning there'll be an entire plenary session on dual aspect monism, so you will have a chance to learn more about it. But this is kind of a version of it. And so one of the slogans here is to say that Soma is significant. And what that means that each somatic configuration can carry a meaning, at least potentially. Elsewhere, Bohm defined information as a difference of form that makes a difference of content. But then this is kind of a way meaning and information relate. And a simple example would be for example, the physical marks or differences in the screen would carry a meaning which is apprehended by you, the reader. And this typically requires a somatic process with many stages. So first, light waves carry the meaning to your retina, and from there it's carried somatically by further processes deeper into the brain, and then it would be in the end apprehended by ever higher intellectual and emotional levels of meaning. And this kind of Bohmian jargon, but this is sort of I think the idea is to think of the brain in a hierarchical fashion. And then as this takes place, these meanings along with their somatic concomitants become ever more subtle. So this is another kind of concept that he wanted to bring in as to characterize and make a distinction between, in this case, between the subtle and the manifest. Because you see, in a way, philosophy is all about making distinctions. Sometimes, like in the case of Descartes, when he was very young, he distinguished between mind and matter, and or consciousness and matter, and spent the rest of his life trying to bridge them. And here, of course, we are, considering another distinction, the subtle versus the manifest. Idea being that this should be useful if we want to understand ourselves, if we want to understand how our mind and our body work, and to get to these two-way traffic that I promised to show you. So anyway, but this kind of, some philosophers or my friends, colleagues, they just think, wow, this is too vague, but let's bear with it for a while. And so therefore, it's not only Soma and significance, there's also these aspects, subtle and the manifest, which this is the way reality will show itself to us. That's what it means to say that it's an aspect. So it's kind of way a side of reality, or from a, if you like, given perspective. So here it goes. You could say that each somatic form, such as a printed page, has a significance, at least potentially. And if you think in terms of, so what does the subtle do here? Well, you could say that the significance is more subtle than the somatic form itself. But then this significance can be held in yet another somatic form. So when you're reading the newspaper, it's, it could be out there in the paper, but then once it gets into your brain, then it's the physical process carrying that meaning will be more subtle. So this is the way we are going toward the more subtle levels, if you like. And then again, what is manifest on one level may be subtle on another, so there's this kind of, this is a relative distinction. And as you go to those higher levels, you might even have a flash of insight. And the idea here is that there's this notion of grasping, that somehow the way the Bohm is thinking here is that when we understand, when the brain understands this, so there's certain meaning being carried by a physical process of certain subtlety. It requires a more subtle process to grasp or understand that. So it's kind of, to some extent, you could even see that as a kind of, it's kind of a materialistic view of understanding. But of course, each level will be, there's the meaning is there as well as the other aspect. So it's not purely materialistic. But it's still fairly physical, if you like, to think about this. One physical process understanding a less subtle physical process. That's how things supposedly are understood. So anyway, now, so this is the Soma significant relation. What you might call, we've been focusing the significance of Soma, the idea that each somatic configuration carries a meaning, at least potentially, and it's this meaning that will be grasped at these more subtle levels of Soma. And that's sort of one side of the overall process that's taking place. But there is another side, and this we can call the signosomatic relation. The idea here is that every meaning at the given level is seen actively to affect the Soma at a more manifest level. And this is, of course, very interesting for mental causation. Philosophy is full of papers claiming that, mental causation is not possible, free will doesn't matter, and this whole business. But of course here we are in our very theoretical scheme. We're claiming that actually meaning is able to affect the Soma, or matter physically. So this is why, one of the reasons why I think these are valuable and interesting things. So you could take an example, shadow seen in a dark night. If this is interpreted to mean an assailant, it will have a powerful physiological effect, and with the adrenaline and so on. However, if it's taken to be just a shadow, the response of the body will be very different. So the lesson here is that quite generally, the total physical response of the human being is profoundly affected by what physical forms mean to him. And so a change of meaning can totally change your response. So if you reinterpret, you thought it was an assailant, oh, it's just a shadow, very different response. And Bohm had these slogans like meaning is being, or a change of meaning is a change of being. He wanted to apply this in politics and dialogue and everything, but I won't go in there today. Although we probably need a coherent meaning in the world today, right? And a change of meaning and a change of being. Sorry. And of course, meaning here is very contextual, so it will vary according to all sorts of things. So ability, if I don't know Chinese, then it won't mean much to me if I read a Chinese newspaper, or you might not get much if I give you a Finnish newspaper, but if you have abilities, then that meaning will be there. And of course, all background and conditioning, and this is kind of taken into account here, which is well known. And we can move on to the action perception cycle, because we're still at the signosomatic phase where we think that meaning is being unfolded somatically toward this more manifest level as an activity. And finally, this would lead to action. Action would emerge as a physical movement of the body that affects the environment. There's a lot of discussion in philosophy about action. And again, here I think one could bring from here something quite valuable there. Because I think a lot of philosophers, even today, they take a very simple-minded view of the physical world. And this kind of dominates philosophy of people talking about action. But here we want to claim that actually meaning in a very powerful, fundamental, natural way can actually guiding our actions. So now we're getting there. We're getting to this two-way movement of energy in which each level of significance acts on the next more manifestly somatic level, while perception is there, carrying the meaning of the action back in the other direction. And of course here is the possibility of learning, and this can of course be connected to like predictive processing, which is a very popular now, that a lot of the top-down signal-somatic processes could also be predictive, but then we get perception, especially and feedback from our actions will lead us to update our models, so this will be consistent with the predictive processing models. But again here I want, it's important here is to just see the two-way traffic that we have here. And this is schematically showing that going from left to right, you're going toward the more subtle levels, and then at some stage it will kick back. And of course here, not everything needs to be conscious. I think this Bohm's view of meaning was of course to think of meaning as something that can happen without consciousness, although of course the interesting thing is then consciousness experience as such. And so you could say that nothing exists in this process except as a two-way movement, a flow of energy. So if you want to meditate, or if you want, think about these ideas, you could feel that this is what's going on all the time in us. To be a human being is to have this process where perception is carrying information to these higher levels, and at the same time there's already this sort of signal-somatic process. And so, and this is what Bohm called this overall structure of meaning that then we grasp in every experience, okay? And there's even in the sense that we could discuss, well, what about mind and body? I mean, is there any sense in which mind would be autonomous here? And the way it works here is that as we go into these higher levels, then you could have processes where these more so-called more subtle levels start looking at themselves, so to speak. And you get a situation where you have an activity in which it's not strongly coupled with any outer physical manifestation. So this would be the mental side of experience. So what we could say this is what we call the mind. But of course, I mean, in the paper where Bohm writes is, the moment he has said this, he's immediately saying that he doesn't want to say that the mind would be in any way strictly separate from the body. It is just not strongly coupled. But the connection is still there. And then once we go toward actions, then that's when we go to the physical, what we traditionally call the body, okay? And so Bohm himself, he did not emphasize the interactionist character of the Soma significance scheme. Some of you know that he has this other scheme, the implicate order scheme, which had a more exotic idea that mind and body are correlated projections from this multidimensional reality. And in this picture, any interaction between mind and body would go via this ground and not via levels such as in the Soma significance scheme. And for whatever reason, I've always been attracted with the kind of interactionist reading or picture here. And this is, in a way, what I'm talking about today. Of course, being open to these possibilities of this correlated projections view. I think the philosopher Yenan Ismail actually wrote recently an article about looking at this Bohm's correlated projection ideas, but anyway. And so you see, because I would suggest that in this, if we take this pilot wave framework, it's possible to think of the relation of mind and body as a kind of interaction. Just as we say that the pilot wave acts on atomic particles, we can say that a given mental state can act on lower level mental states. And these mental states, in turn, act downwards all the way to the particles and other fields in the brain, for example, in synapses or neural microtubules. So one could try to connect all the work that, like Stuart, Penrose, all the others are doing, could be very useful for this scheme as well. And but this is not interaction between separate substances. It would be interaction between the subtle levels and manifest levels mediated by information. And so that's why I don't know, I'm so old, so I maybe must have an ism to sell like everybody else. So why not call it an interactionist monism? Of course, it may sound as a contradiction in terms because, you know, interactionist is two different things, monism is one thing. But, you know, here we have like, you know, aspects or levels of the same substance, if you like. Now, Bohm himself felt that we should use the term participation to describe the relationship between the levels. But why not interaction? Because the subtle levels can act on the manifest and vice versa, like in perception, also learning. Monism, because the levels are similar. And importantly, even at the quantum level, it has a primitive mind-like aspect, this information carried by the pilot wave. And that again means that it's a dual aspect monism. And so we don't have two substances, we have these manifest and subtle levels of the same substance, if you like. And so finally, just very briefly about consciousness, we could ask whether Bohm's approach might help us to understand how consciousness arises. We didn't discuss that so much because, you know, we did it in the late 80s, so the consciousness, this thing hadn't happened yet. But anyway, as you know, these are now the main types of theories in contemporary consciousness studies. And this is a review paper by Seth and Bain. And they even mentioned quantum theories of consciousness. I didn't discuss them, but, and of course now they, you know, anyway. But this is just to quickly say that just like that, the mind-matter scheme that I've discussed, we could make use of high-order theories because there is this hierarchical levels. Also, this quantum field for many-body system could be seen as a kind of global workspace. This Bohm's active information at the quantum level is holistic and involves non-locality, so it may be an example of highly integrated information if we would want to go to that direction. Jack Sarfati has made long ago, actually I think it was in Tucson, 96, he suggested that he looked at the Bohm model and he suggested that consciousness arises as matter acts back upon the intrinsically mental quantum information field. So this is an exciting idea because, of course, you're easy in the panpsychism there, but there's still, I think it's an idea worth exploring. And as I kind of hinted, quantum active information could be added to Penrose and Hameroff's or quantum theory of consciousness. Of course, from Penrose, one would get this non-computational collapse. I mean, although the pilot wave model, as such, usually there is no collapse, but if you want, you can add. Bohm and Hiley discussed that a little bit as well, and that way one could get both information and non-computation at the quantum level, making it kind of a stronger theory of mind and even consciousness. But anyway, so these are just schematic suggestions. I would say that the advantage of the Bohm approach is that this notion of objective and active information is extended to the quantum level. The claim is that there exists a primitive mind-like pole even at the quantum level. So we do not ask how can a purely physical system give rise to conscious experience, which would be, Chalmers' heart problem. We ask how can a system where each level has a physical and a mental or informational aspect give rise to conscious experience. And that's it. Thank you very much.
Thank you. We have a couple of minutes for questions. Go ahead.
Paavo, thank you very much for your talk and your work with David. did David ever bring up the concept of retrocausality in quantum systems?
Can you speak to the mic?
Yeah. Did David ever bring up the concept of retrocausality in quantum systems?
Not that I remember. But of
Thank
course,
you.
others have done it, like Hugh Price.
Well, and
Yeah,
Jack as well.
Yeah, that's right. Yeah.
Hi, Paavo. Thank you. Great talk. So I just have a question about the last point you make. So it seems you are referring to different theories.
Which one? This one?
The next one. So I'm interested in conversions on theories of consciousness. So I think that this quantum approach could help us to find some conversions between different theories. So you mentioned IIT, global neural workspace theory, and orchestrated objective reduction. So I just wonder if you find some kind of this approach, the quantum approach can help us to find some conversions in the theories.
All right. So can you just summarize again? I had difficulty of hearing the question that.
Yeah, I was just curious what is your main point here? If you think that the Bond's quantum approach could help us to find some conversions between different theories of consciousness.
Right. Yeah. Well, fair enough. I mean, here I've just showed quickly that how you could connect with some of these other schemes. And people are trying to. There's some other people like Graziano wrote a paper where they tried to bring together higher order theories, this attention schema theory, and I think illusionism. So people are trying to bring the theories together, and there's a lot of, if you like, meta-level methodological discussion in consciousness studies that instead of just adding more and more theories, we should try to look for some sort of minimal model, like Vanja Wiese has an interesting paper like that. So I definitely think that one could do here, because of course the scheme that I talked about it's very general. I think the key point here is to show that physics itself, one thing is that we can introduce new concepts to physics, non-mechanical concepts like active information. If we do that, then we are able to think in a new way these traditional philosophical problems. So we could liberate consciousness studies from this very old-fashioned materialism, but perhaps not go all the way to idealism or panpsychism if we don't want to go there.
Hello. I think this is brilliant. In my mind, I kind of, when you're talking, saw it as like an infinity symbol where they're feeding back on each other. And when you talk about the middle thing, what gives meaning or being or information, that was the word, right? Information. I feel like you're proving in a way, and maybe you don't agree, but that's okay, that humans are special because we're in the middle of everything and we can experience all of this. And a lot of the thoughts right now are about consciousness and awareness and how important we are out of our bodies, but I feel like this kind of proves how important the human experience is for us to grow and evolve. Because when we're dead, we can be awareness, and that's great. But like right now, at least to me, this proves how special we are as humans. So I love it.
Yeah.
Thanks. Yes.
Okay. Fair enough. I mean, I think that's of course through our language and all, it gives us rich possibilities with meaning. But let's have another. What do you have?
Hi.
Yeah.
Thank you. Great talk. I was just wondering, are you familiar with Shelley Joy's work on specifically related to the Fourier transform?
Can you say again which work?
Are you familiar with Shelley Joy's work, particularly with the Fourier transform?
Probably not.
Yeah, so she did her dissertation as a combination of David Bohm, Karl Pribram, and Pierre Desjardins' work. And so there's a really great quote, my phone just died, of course, but where Karl Pribram is using the Fourier transform, this 17th century mathematician, figured out how to convert energy from the time domain to the frequency domain. She uses it to explain the relationship between mind and body. I think you might find it interesting. So she's her undergraduate degree was in electrical engineering, but then she went to California Institute of Integral Studies with a master's in Hindu philosophy and a PhD in philosophy, cosmology, and consciousness.
Okay.
So, yeah.
No,
Anyway.
but that'd be very interesting. Of course,
Okay.
the pre-Brum work is one way with this holographic memory, and it's one way to connect to these. But it's more to the Bohm's implicate order program.
Exactly. Yeah, the
Right.
relationship
Which
between
is, of
implicate and
course,
explicate.
an- another
Okay.
Other
Cool.
one.
Thank
Yeah.
you.
Yeah, thanks.
Yes, thank you so much for this very informative talk. And yeah, it's some aspect I did not realize about Bohm. And it's very interesting because we have a proposed way how to integrate, to use quantum physics to study consciousness, and actually use the exactly same idea. Realize the quantum physics is actually studies this active, objective information. And that is part of the ingredients of everything. You know, everything is a quantum field and carries this informative, objective, active information as part of what everything is made of. And so by doing that, we actually can address the mind-body problem. In fact, we can even give a definition, quantum physics definition to what is a spirit, what is spiritual heart, and what is mind, and use quantum physics to study them. Yeah. So if you want, I'd be happy to share some more papers. You can give us some critical review.
Yeah, thank you very much.
Thank you.
Yeah, that's okay.
Hi, thank you for speaking. My name is Ava Satnik. I'm a physician by training, and I was just taking your terminology and relating it to my experience with patients. So for my, and just asking for clarifications, if this is how I may be able to relate to it, is if the body is the soma, and the mind is the information that propels the body. And to me, I guess the body clearly has form, thoughts have form, but other parts of this information maybe doesn't. So that's where it's a little ambiguous for me. And then consciousness is formless. So there's a stream going from consciousness, and I could be wrong, and you'll have to let me know if I am, from my understanding. So the stream of consciousness is coming through its meaning and propelling the body forward. But the question I have is, does it also go, if that's true, can it also go the other way?
Well, you mean like the soma
inform-
significance, how this, the two directions, of course, the signal somatic is when meanings typically organize the lower levels, and whereas the soma significant is where information is carried towards. So it's asymmetric in the sense that, at least in this original scheme, that in the signal somatic is an organizing process. Of course, it's there even in quantum mechanics, because then like in superconductivity and those examples that are given, then this field of information will organize the movement of the particles. But then when you have the other way, in perception, it's perhaps more just gathering of information, and so in a way, the bottom-up process is not. Of course, it will give form to various processes. It will influence things, but I guess the idea here is also that the input will be interpreted, and then that of course depends on contextual factors. So in that sense, maybe any information you get in doesn't automatically determine what will happen. So in this sense, this picture perhaps emphasizes this so-called top-down in
Can I ask
in psychology.
Yeah, so there's a practice of somatic guided meditation where you have someone feel their body and the sensations they have in their body, which provide them information. And then they're in a state of like, we'll call it subconscious for lack of a better word, right? And then meaning comes from those sensations. and then that gives light to like what their experience is or what their conscious is. So like in my experience, like I've seen it happen the other way.
Okay, yeah. Yeah, but I guess I can't quite, I wouldn't know.
Can it be explained?
Yeah.
No, okay.
Yeah, thanks.
Okay,
All right, thank you. I think we'll close the session.
One more,
Paavo
please.
is here.
One more, please.
I think you can come up and talk to Paavo. I think
Okay.
that's fine. Yeah, thank you.
Yeah, thank you very much. Thanks.